Greetings, learners. Back to the class, back to the lesson. We are now going to be taking another part of the climate and weather for grade 12. I'm being specific for grade 12 because you are going to find this same topic for today called secondary circulation in the grade 11 annual teaching plan and your syllabus as learners. But I want to attempt it so that it lays the foundation for your understanding of mid-latitude cyclones and also tropical cyclones. Because it is very, very important that you grasp secondary circulations if you are going to be able to feed into your tropical cyclones and your mid-latitude cyclones with understanding. Let us start with the first slide. Now, remember, when we are talking about secondary circulation, you have moved from the broader global circulation. You are now having chunks of the continents and chunks of the areas that are having specific types of belts and pressure zones. So when you have your globe, try to subdivide it and make it standard. Don't do it differently. From your 0 degrees along the equator, your next line of latitude must be 30 degrees north and south. And your next line, as you move towards the poles, must be 60 degrees north and south, right until you have your North Pole and your South Pole. Now, if you look at this, it was attempted in grade 11, as I've mentioned before, but it was under the topic of theoretical pressure belts. Theoretical pressure belts. So I'm not going to be going deeper into that because it was done, I would assume, thoroughly. But now we are going to focus on laying the foundation for what we want to do next. Okay? Now let's look at that. Along the equator, you can see already it's a low pressure belt. Now, once you get a low pressure belt, you must associate that with high temperatures because it's a negative relationship. The higher the temperature, the lower the pressure, okay? So you can see from the right, along that pressure belt, it will be very, very hot. And the air will be rising, which is ascending. And we call that convection currents. Convection rising. And again, low pressure is very specified because that is a defining moment. That is where you have thermal rising because of the great heat that you get there. Now let's look at the next one. 30 degrees, high pressure, subtropical high pressure. Here the air from the equator sinks, okay? Other candidates will prefer to use descends. But in essence, the correct geography term is subsiding. Is subsiding. So if you had an option, I would recommend that you use subsiding. But in the exam, we do give a mark for sinking, we do give a mark for descending. But as I said, the geographically correct term is subsiding. That is an area with a high pressure. Okay, so high pressure also speaks to a low temperature. Okay, now let's look up there near the poles. Again, it's a high pressure. And what does that mean? Very cold areas. Remember, the more you move towards the poles, the lower the temperature. Again, likewise, because these are both high pressures, there'll be subsiding air. And that is, as we said, air that descends. The air that descends. Or you can say air that sinks. Okay? Now, let us look at 60 degrees, the subpolar low. Often referred to as the polar front. This is where the cold air from the polar high meets the warm air from the subtropical high. They meet along the subpolar low pressure. Again, wind back. Where there's a low pressure, there'll be surface convergence of air. So you can see there, they meet there, the cold air from the polar high and the warm air from the subtropical high area. They meet in the subpolar low pressure. That is known as the polar front. It's got very, very particular weather systems, like your jet streams and so on. I think you must have heard about those from grade 11, okay? Now, I want to talk about the westerly wind belt, because as you move on to talk about your mid-latitude cyclones, you will need that information, okay? In the westerly wind belt, you get wind that was supposed to move from a subtropical high pressure towards a subpolar low pressure. Look at the pressure gradient force. There it is, from a subtropical high pressure to a subpolar low. But it was deflected to the left in the southern hemisphere. Now it ends up moving from west to east. Hence you call it the westerly winds, okay? Now, let's go back to something. If you look at this area, that area is between 90 degrees and 0 degrees. So the 30 degrees to 60 degrees is in the middle. So we refer to those areas as middle latitudes. Hence, this area will be laden with mid-latitude cyclones. So in terms of location, that is where you will find your mid-latitude cyclones. That is why they move from west to east, because they are carried by westerly winds. That's why I said, dear learners, dear candidates, we are going to be using this secondary circulation as a basis for understanding other topics that we are going to be having when we are going further, like mid-latitude cyclones and tropical cyclones, okay? Now let's take the next one. Look at that. Tropical easterlies. Easterlies means they move from east to west. Easterlies. Now, before we go any further, let us understand that tropical easterlies are also known as trade winds. Those are the two common names. Now, I'm giving you all these alternative names so that when the examiner decides to use one and not the other, you are not lost in the exam. Now, these are tropical easterlies, okay? Now, let's see where it all starts, okay? Here you have got air moving from an area of a high pressure to an area of a low pressure, from the tropics, converging along the equator. Hence, that is called the intertropical convergence zone, ITCZ, okay? But it doesn't really end up that way. Look at this deflection of wind. Now, it is a deflection to the left in the southern hemisphere, okay? A deflection to the left in the southern hemisphere and to the right in the northern hemisphere. Already, if you're a wise learner, you know that that is the effect of the Coriolis force, because the Coriolis force is a deflecting force. It deflects winds to the left in the southern hemisphere and to the right in the northern hemisphere. Now, in the tropical easterlies belt, that is where you get your tropical cyclones. And they move from east to west and away from the equator. What does that mean? East to west and away from the equator in the southern hemisphere, east to west and away from the equator in the northern hemisphere. If you look at it, this is to the right and this is to the left. Now it shows you clearly the effect of the Coriolis force. Now, why do tropical cyclones move from east to west? Because they are carried by the tropical easterlies. I hope, learners, this has given you enough of a background to understand what is happening here. And let us move on to show you something that is not usually available to you as candidates, okay? Okay, let's wrap up the Coriolis force. Winds deflect to the right in the northern hemisphere and to the left in the southern hemisphere. Now, don't say to the left and leave the hemisphere, or say to the right and leave the hemisphere. It's never going to give you marks in the exams. It's going to give you trouble only. You'll get a 0 for that one. Okay? Now, this is Professor Gustav de Coriolis. So when you talk about the Coriolis force, there is a professor of physics and a professor of geography that was actually behind that. And the person is Gustav de Coriolis. He lived in 1792 to 1843. Dear learners, just try to go the extra mile. Show some passion. Love geography, and you'll enjoy it. Once you love something, you enjoy it, it becomes easy for you to live it, and you can get your level 7.